Good evening everyone. In this session let us see long answer questions of our first year. So in the previous sessions we have seen very short answers and short answer questions, right? So in this session let us see long answer questions. So in these long answer questions will come in your section C and you have only one choice. So what you need to do here is you need to write each and every answer clearly, because this is the highest mark which is in the question paper. So let us see a question. What are the postulates of Bohr model of hydrogen atom, and discuss the importance of this model to explain various series of line spectra in hydrogen atom. So this question is regarding the Bohr's atomic model. So Bohr's theory, what the final conclusion we get in the Bohr's theory regarding hydrogen atom, and this is one more question added regarding the series line spectra of hydrogen atom. So let us see what is Bohr's theory first. So whatever you write in this long answer questions, you need to expand it clearly, because this is the long answer. So let us see the postulates of Bohr's theory. So what is Bohr's theory? The electrons revolve around the nucleus in certain definite circular paths. So what are those circular paths are called? They are called orbits. So this is the nucleus, and the electron revolves round the nucleus in certain definite paths. Here is the electron. This electron revolves round the nucleus in certain path. They are called orbits, and these are also known as energy levels or shells. So for every element there is a nucleus. This nucleus is surrounded by revolving electrons. Those electrons revolve around a circular path. They are called orbits or shells. So this is the first postulate given by Bohr. And next, each orbit is associated with definite amount of energy. So the shells which consist on which the electron revolves, they have particular amount of energy. So these are known as, this energy of this shells is known as energy shells, and these orbits are denoted by the value of n, and mainly K, L, M, N shells, etc. shells. We'll name this as K, L, M, N shells. K means the first shell, L means the second shell, M means the third, N means the fourth shell. This N denotes the value. And next, as long as the electron revolve in the circular orbits, they emit or absorb energy. They neither emit nor absorb in their energy. It means if the electron revolves in its own orbit or the path, it does not absorb or does not release any energy. That's why they are called stationary orbits. I'm saying about the original path of the electron in which it revolves, it does not emit or absorbs energy. That's why they are known as stationary orbits. And more than one stationary orbit is possible for any electron, because there are more number of shells, there may be more number of stationary orbits. And the angular momentum of the revolving electron is quantized. So here you have a word, quantization. What is quantized here? The angular momentum. Angular momentum is quantized. It means it is multiplied by n times. Quantization means multiplied by n times. So what it is multiplied? It is quantized with the integral multiple of h by 2 pi r. It means the angular momentum, which is mv. This is quantized. It means multiplied n times of h by 2 pi r. If we take r to the left side, it becomes mvr is equal to nh by 2 pi. So what is this? Bohr's energy equation. Momentum is quantized as nh by 2 pi r, where if r is to the left side, it becomes mvr is equal to nh by 2 pi. So until this is the Bohr's model of hydrogen atom, Bohr's theory, where expand all these terms, where m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit in which it is rotating, and where h is the Planck's constant, n is principal quantum number, it means in which orbit it is rotating. So this is the first part of the question. Let us see the next part. And we have one more postulate here, and the energy of the electron changes. See, in stationary orbit there is no change in the electron. When the energy changes, it means when the electron shifts from one orbit to the another orbit. When electron jumps from one orbit to the other, then there is a change in the energy. It means either energy is absorbed or released. So when the energy is absorbed, when the electron jumps from lower orbit to higher orbit, lower to higher, it means 1 to 2. What happens here? Energy is absorbed. Similarly, when the electron jumps from higher to lower, it means it will return back to its first orbit. What happens here? Energy is emitted. So if we take energy levels as E1 and E2, when it moves from E1 to E2, energy is absorbed. When E2 to E1, it is emitted, where this energy emitted or absorbed is given by h mu. See here, E1 is the energy of the lower orbit, E2 is the energy of the higher orbit, and delta E. Delta is the difference between the two energy levels. This difference is equal to Planck's constant into frequency, that is h into mu. So till this, these are the postulates of Bohr's atomic theory. And next let us see the next part, that is about the hydrogen spectrum. So explain what is hydrogen spectrum in a very theoretical way, like it is shown in the slide. So what this hydrogen spectrum mainly says is, in a hydrogen atom, what happens in a hydrogen atom? How many electrons are present? Only one electron is present in the hydrogen atom. It is in the shell where n is equal to 1. Right? If this is in its stationary orbit, there is no emitting or absorption of energy takes place. When there is external energy is provided, it means the electron may get excited to higher energy levels. What happens? Energy is absorbed, and that energy absorbed, which is taken by the electron, will be released when it is moving from higher energy to lower energy, like we have seen in the sixth postulate of Bohr's theory. When the energy moves from lower to higher, energy is absorbed. When it is moving from higher to lower, energy is emitted. So in this way, when the one electron of this hydrogen moves to its higher energy levels, so these levels, let us take first energy level, that is n is equal to 1. When the electron moves from, you can see here, higher energy levels. Those are named by certain series. They are Lyman series. It means, you can see this statement, some excited electrons may come back from any of the higher energy levels to the lower energy level. It means if it is excited to any of the higher energy levels, but still it reaches to the first level, first energy orbit, that is n is equal to 1, that series is known as Lyman series. This Lyman series is formed in the UV region, ultraviolet region, and when excited electrons come back from any higher energy level to the lower energy level, that is n is equal to 2, then that series is known as Balmer series, and this is formed in the visible region. And when excited electrons come back from any of the higher levels to third, fourth and fifth levels, those levels are named as passion, bracket and fun, and this happens in the IR region, that is infrared region. First excitation takes place since when the electron reaches its higher energy level of orbitals, it is highly unstable. It will readily come back to its ground state. During this ground state, it may reach directly to the first orbit, or it may reach to the second or third or fourth or fifth, depends on which it reaches. Certain names are given and certain regions are also given, like UV, visible and IR regions. Okay, mention them in the theory first. Let us see one example. For example, de-excitation. It means already electron is excited and it is returning back to the ground level. That is the de-excitation. Process of an electron takes place from fourth energy level to the first energy level. It means it reaches to the fourth level, excited, highly unstable, then it comes back to its original state, first level. This de-excitation may be in the form of a direct step. It means directly it reaches from 4 to 1, or it may be of different steps from 4 to 3 or 3 to 2, 3 to 2 to 1, or 4 to 3 to 1 or 4 to 2 to 1. It means there are certain orbits which this electron may travel from, or it can travel from the direct step, like you can see in this figure. You can see when electron first it is present in this n is equal to 1 state, and when it reaches to the fourth level, what happens? This electron becomes highly unstable. This may return back directly to the n equal to 1 in a direct step, or from 4 to 3 or 3 to 2, 2 to 1, or in different ways. In different ways, there is different absorption or release of energies. Since it is de-excitation, release of energy takes place. So this different series of de-excitation takes place, as we have mentioned, in the name of Lyman, Balmer, passion, bracket and fun. So this is the diagram, energy level diagram of hydrogen spectrum. So this is also very important one. So in this way we can arrange these lines and the regions where it is available. So you need to mention in this way. It is a lot of time taking, but you need to mention it clearly to get good marks, right? And next we have one more question. What are quantum numbers? So this is also one of the important question. As you know, this quantum numbers is the important topic of this unit. So we have how are the quantum numbers n, l and m arrived at? It means how they are derived, and explain the significance, importance of this quantum numbers. We all know we have 4 main important quantum numbers. They are principal quantum number, which is denoted by n, and azimuthal quantum number denoted by L, magnetic quantum number denoted by ML, and spin quantum number denoted by ms. So let us see, you need to write each and every quantum number in a detailed way. Let us see first the principal quantum number. So this was proposed by Niels Bohr, as we have seen in the last question. Bohr's quantum number, the energy shells, it is denoted by the letter n. It represents the circular orbits around the nucleus. So this is nucleus. So the circular orbits around the nucleus are represented by this n value. As the value of n increases, the size and energy of the orbit increases because more number of shells are added. According to number method, it has the values of 1, 2, 3 as we have discussed earlier, and this n can be represented as k, l, m, so on. So in any orbit, the number of suborbits, that is equal to n square. The suborbits can be derived in the formula of n square, and this quantum number describes the size and energy of the orbit, right? And next, what is this azimuthal quantum number? It is denoted by L. This was proposed by Sommerfeld, and this quantum number is known as angular momentum quantum number, and this is denoted by the letter L. This quantum number represents the sublevels present in the main levels. It means for K we can see S, for L we can see S and P. In that way it is represented. So these sublevels are S, P, D and F. So these are our non-subshells, and the L values of subshells will start from 0, 1, 2, 3, and whereas the orbits start from 1, 2, 3 and n values. Those are the n values starts from 1, 2, 3, and this L value starts from 0, 1, 2 and 3. And the first main level contains only one sublevel. It is S. This is the main level, the S K shell, which has only S. The second main level contains S and P sublevels like this. L has S and P. And the third, for example, it is M. It contains S, P and D sublevels. So the fourth main level, which is, if suppose it is taken as N, it contains S, P, D and F sublevels. So this is about azimuthal quantum number. So you can see here, if it is main level 1, that is, it may be the K, and 2 means it may be L, 3 means it may be M, 4 means it is N. So these sublevels, in first sublevel we have S, that is 1S, that is 1S sublevel, and in second one S and P are there, means 2S and 2P. It means for every sublevel there will be a numbering of the main level before it. You can see for 3 sublevels SPD, it means 3S, 3P and 3D. For 4, 4S, 4P, 4D and 4F are present. And next, the relative values of 1S, 2S, 2P can be calculated by adding up their N and L values. You can see the energy value of 1s orbital, 1 is directly taken as 1, and S value for L value, S value of S for L value it is 0, right? So the energy level is 1. For 2P, 2 is the main one, so it is written like that, and P carries, P is equal to 1, L value of P is 1, so this complete energy is 3. And you can see the sublevels in this column and the L values in this column. S is 0, P is 1, D is 2 and F is 3. The M values, it is the values of the magnetic quantum number. These M values for S it is 1, right? For 1s it is 1. Since S is 0, we have M value as 0. 0 means it is a number, right? How many orbitals? 1 orbital. For P it is 1. It means it ranges from minus L to plus L. This M value ranges from minus L to plus L, in which 0 is also included. So you can write here P as minus 1, 0 and plus 1. Completely there are 3 number of orbitals. For 2 there are 5 number. For 3, minus 3 to plus 3. Completely there are 7 number of orbitals. So these are the energy values and the M values, and this quantum number describes the shape of the orbital. It means every orbital have certain shape that is shown by this azimuthal quantum number. S is in spherical shape. So this is the very important point in describing this orbitals. This S is spherical, P is dumbbell, D is double dumbbell and F is fourfold double dumbbell. You can see this. You need to write this column also. And next we have magnetic quantum number. This was proposed by Lande. It is denoted by M, and this quantum number describes the sublevels of M orbitals, the sublevels of orbitals present in the given sublevel, as we have seen in the table. M value ranges from minus L to plus L, including 0. And this total number of M values gives 2L plus 1. It means this number of orbitals. This is given by the formula 2L plus 1. This is the point. And next, all the orbits present in the given sublevel possesses the same energy values because they possess the same N and L values. And next, this quantum number describes the orientation of orbits in space. Orientation means the revolving of the orbitals in space. It is given by this magnetic quantum number. And next, fourth main quantum number is the spin quantum number. It was proposed by Uhlenbeck and Goudsmit. So this is denoted by Ms. Magnetic quantum number is denoted by M value. ML, this L is ranges from minus L to plus L. This spin is denoted by Ms, and this quantum number describes the spin of the revolving electron. Spin, in the name itself we have spin, means the spin can be described by this quantum number. This Ms value of clockwise electron is plus half and that of anti-clockwise electron is minus half. It means if the electron rotates in a clockwise direction, its value will be plus half. If it rotates in anti-clockwise direction, its value is minus half. This describes the direction of spin of the revolving electron. So this is the description about this quantum numbers. And next, one of the important concept, what is periodic property and how do the following properties change in group and period? Explain. So what is the periodic property? The property which explains the nature of the element. So which explains its nature, those are known as periodic properties. So let us see what is given in the question. To check how the atomic radius changes in a group and a period, and how the ionization energy changes in a group and a period, and about the electron affinity, and about electronegativity. And one more question is added. Explain the ionization energy order in the following sets of elements. We have few elements here. So let us see the first part. The property in which there shall be a regular gradation is called periodic property. It means there will be some changes as it goes from left to right or top to bottom. That type of properties, those are mainly known as the periodic properties. What is the first one given? Atomic radius. What is atomic radius? Here is atomic radius. Excuse me. What happens about this atomic radius in a period? In a period, as we move from left to right, what happens? Assume a periodic table. If we move from left to right, what happens? Atomic radius. What happens about the atomic number? Atomic number increases. It means obviously atomic radius will also be increased. So that is what you need to write. So atomic radius of elements, atomic radius of elements decreases across a period from left to right because the nuclear charge increases due to increase in atomic number. So sorry for the explanation. See, if it is in a period, what happens? From left to right, what happens? Atomic number increases obviously. And what happens to the nuclear charge? Nuclear charge, it also gets increased. If nuclear charge gets increased, what happens? It attracts the outermost electrons very effectively. It attracts outermost electrons strongly. What if outermost electrons are attracted strongly? It means there will be decrease in atomic size. If there is strong attraction on the outermost electrons, what happens? The size of the atom will be decreased. If the size is decreased, what happens to the atomic radius? It will also get decreased. So this is in a period. What happens in a group? It is opposite now. As in a group, what happens from top to bottom? A new shell is added. A new shell is added. It means obviously the size will be increased. So radius of the atom from top to bottom will be increased. So atomic radius will also gets increased. And next, ionization energy. So what is ionization energy? The minimum amount of energy required to remove an electron from its outermost shell. So that is ionization energy. What happens to the ionization energy? In a period when we move from left to right, it does not follow a regular trend, but generally it increases due to increase in the atomic number. Why it does not follow regular trend? We will see it. Because you can see this in the next question clearly. And what happens it in a group? In a group from top to bottom, what happens? A new shell is added. It means the ionization energy decreases due to increase in the atomic size. So this atomic size is the main factor. And next, electron affinity. So what is this electron affinity? The energy released when a new electron is added to a neutral atom. This is electron affinity. What happens if it is in a period? This values increases from left to right in a period. It means the electron affinity values will increases. In a group, it will be in opposite way. It will decrease from top to bottom in a group. And electronegativity, the amount of energy required to attract the electrons, that is electronegativity. As atomic size will be decreased from left to right in a period, what happens? The attraction power will be more. It means there will be electronegativity increase. In a group, what happens? It is opposite, it is decreased. So as we have discussed, to see the ionization energy, how it varies, and but generally it increases in a period. Let's see by this second question regarding examples. See the ionization order for Na, Al and Cl. These belongs to same period, right? Same period, second period. So what happens in a period? Ionization energy increases. Here what are there? Sodium, aluminum and chlorine, right? This sodium is having atomic number of 11 and aluminum as 13 and chlorine as 17. So write it in its outermost electronic configuration. This has two S1, this has 2S2, 2P1, this has 2S2, 2P5. So in its outermost it has 1 electron. It is having 3 electrons and this is having 7 electrons. So here the ionization energy value increases. It means the electron we need to remove from chlorine requires more ionization energy compared to that of sodium. And for lithium, beryllium and boron, they are first period elements. Lithium, beryllium, boron, 3, 4 and 5 atomic number elements. What happens? Beryllium has stable configuration. You can see beryllium. This lithium has here it is 3, and this lithium, it is having a configuration of 1s2, 2s1. This beryllium, it is 1s2, 2s2, and this boron, it is 1s2, 2s2 and 2p1. You can observe for beryllium, it is 2s2 in its outermost orbit. It means it is a completely filled orbit. So whenever there are completely filled or half filled orbits, half filled orbitals, what happens? The energy required, the ionization energy at this stage is very high. So that's why there will be some change in the trend. Since it is a fulfilled configuration, the amount of energy required to remove the electron from beryllium will be more, because this is more stable configuration, 1s2, 2s2. That's why beryllium comes first, next to boron, next to lithium. Similarly, you can see for carbon, nitrogen and oxygen. This nitrogen has a half filled p orbital configuration, a 2p3 configuration, that is a completely half filled. So the energy required to remove this one electron is very high. So that's why nitrogen comes first, next to oxygen, next to carbon. That is the reason it is mentioned here. When we move from left to right, it does not follow a regular trend in a period. So that's why generally it is said as increases when ionization energy, if we compare it in a period. So this is about this question. So if you understand the concept clearly, you can easily answer this. And next, give the molecular orbital energy diagram of nitrogen, oxygen. Write the bond order of nitrogen and oxygen. As you know, these molecular orbital energy diagrams are very important. Let us see for nitrogen and oxygen. See, this is for nitrogen. For nitrogen, atomic number is 7, which is having a atomic electronic configuration as 1s2, 2s2 and 2p3. Let us write the molecular electronic configuration. So molecular configuration is written in the form of sigma and pi, right? So practice these energy diagrams thoroughly. See the difference between nitrogen and oxygen. This configuration, this two nitrogens, which is completely having 14 electrons. These 14 electrons are distributed in this way: sigma 1s2, sigma star 1s2, and this star is anti-bonding molecular orbitals which are having higher energy, and this sigma, this which is simply sigma, they are bonding molecular orbitals. And sigma 2s2, sigma star 2s2 and pi 2py2 and pi 2px2 both are having same energies. And next, sigma 2px2. This is the configuration for nitrogen molecule. Excuse me. And this molecular energy diagram is in this way. So mention clearly everything. And here what is asked? It is asked to calculate bond order. So what is bond order formula? Bond order is equal to number of electrons in bonding molecular orbitals minus number of electrons in anti-bonding molecular orbitals divided by 2. So this is the formula to calculate bond order. Just we can see for nitrogen. This nitrogen has 8 bonding molecular orbitals and star electrons. How many are there? We have 2 electrons in anti-bonding molecular orbital divided by 2, that is 6 by 2. We get 3. So this is, we have 3 as the bond order for N2 molecule. It means N is bonded to another N by 3 bonds. And you can see there are no lone pair of electrons in the molecular configuration. All are paired. Since all are paired, this nitrogen molecule is a diamagnetic in nature. If there are lone pairs, then it will be paramagnetic in nature. Similarly, you can see for oxygen. This electronic configuration of oxygen, that is 8, that is having configuration of 1s2, 2s2 and 2p4. And this oxygen, each oxygen has 8 electrons. O2 molecule will be having 8 plus 8, 16. And this configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2 and pi 2py2, pi 2pz2 and pi star 2py1 and pi star 2pz1 configuration. This is the configuration for oxygen. If this type of configuration is there, calculate the bond order. You will get the bond order value as 2. It means one oxygen is linked to other by 2 bonds. So this presence of 2 unpaired electrons, you can see 2 unpaired electrons in pi star. So these unpaired electrons represents, this is paramagnetic in nature. You can see in this way you need to write the answer for these questions. And next we have what is Le-Chatelier's principle. Very important concept. Discuss briefly the factors which can influence the equilibrium. So this Le-Chatelier's principle is mainly explains about the equilibrium, how the equilibrium shifts in its suitable way. See, let us see the Le-Chatelier's principle. What is this? If a chemical reaction at equilibrium is subjected to a change, it means, for example, if a chemical reaction A plus B is reacting to form C and C plus D, you can see A plus B is reacting to form C plus D at particular conditions, at particular temperature, pressure and concentration. But what happens if there is any change in temperature, pressure or concentration? If there is any change in temperature, pressure or concentration, what happens? This equilibrium will shift in the direction in which the change is reduced. It means it may return back to reactants or it may directly form to the products, depends on the change which is where, in which side, in which reactant side or in product side, where the change is less, the equilibrium will shift to that direction. That is explained by this Le-Chatelier principle. So this mainly depends on pressure. So what happens? Pressure, this pressure is inversely proportional to volume. This is the basic law. Pressure is inversely proportional to volume. It means if pressure is increased, volume is decreased, or volume increases, pressure decreases. For a gas, let us see if it is a gaseous reaction. When pressure is increased in the equilibrium in such a direction that, what happens if pressure increased, volume will be decreased. Decrease in the volume will be observed. Similarly, when pressure is decreased, volume will be increased. So this is applicable exclusively for gaseous reactions, because pressure and volume will be applicable for gaseous reactions easily. So in this way, if pressure increases, volume decreases. If volume increases, pressure decreases, and the equilibrium shifts accordingly. And next, effect of temperature. What happens if temperature is increased? If temperature is increased, equilibrium shift in such a direction where the temperature change is nullified, or where the temperature change is nullified. It means where the temperature change is less or suitable for the reaction, the equilibrium will shift in that direction. And similarly, when the where the equilibrium shifts, there the heat is absorbed. This absorption in the heat represents the reaction will be endothermic reaction. It means when there is effect of temperature, that reaction will be endothermic reaction. And next, when the temperature is decreased, if it is in opposite way, if it is decreased, it means heat is liberated. If heat is liberated, that type of reactions are known as exothermic reactions. And next, this also depends on effect of concentration. What happens if concentration is increased or decreased? Increase in the concentration of the reactants favors forward reaction. It means if concentration of A plus B is increased, the reaction will complete fast, and decrease in the concentration of the reactant favors the backward reaction. So if C plus D concentration increases, this favors to the original reactants. See, when the products are added to the equilibrium, at the equilibrium reaction, the concentration of the products increases and the reaction proceeds in backward direction. That is what we have said. And removal of the products leads to decrease in the concentration of the products. This leads to forward reaction. If any removal of the products takes place, then it will be a forward reaction. And next, this question is about the concept of Bronsted acids and Bronsted bases. So what are Bronsted acids and Bronsted bases? Illustrate with suitable examples. Take correct examples. What is Bronsted acid? Any substance that can lose a proton, that is a Bronsted acid. It means there must be a proton presence in that acid, like we can see in the examples here: HCl, H2SO4, H3PO4, CH3COH. These are examples of Bronsted acids, and which can gain a proton. Opposite to this, which can gain a proton, these are known as bases, Bronsted bases, NH3, H2 and OH minus. These are examples. You can see there is a neutralization. It means when an acid reacts with the base, neutralization takes place. It means there will be a proton transfer from acid to the base. If there is a proton transfer, that type of process is known as neutralization. Here, for example, if we react to HCl with a H2O, a proton transfer takes place from this acid to this water. This water becomes H3O plus and this chlorine becomes Cl minus. So this is also a reversible reaction, and this is the neutralization reaction. You can see Bronsted acid and Bronsted base here, and the acid base pair which delivered by a single proton is said to be conjugate acid base pair. So in the above reaction, HCl and Cl minus, H3O plus and H2O, these are known as conjugate acid base pair because the proton transfer is taking place. And you can see every Bronsted acid has its conjugate base and every Bronsted base has its conjugate protonic acid. You can see here this H3O plus and HCl, H2O and Cl minus. These are conjugate acids and conjugate bases. And this is the few explanation about this theory, and we have advantages of this theory. This theory explains the behavior of acids and bases in both aqueous and non-aqueous solvents. So this is the main use, aqueous and non-aqueous solvents. It also explains behavior of NH3CaO. They are acting as bases, and CO2 and SO2 they act as acids. This is one of the advantage. And the drawbacks of this theory is the proton donation or acceptance happens in the presence of other substances. So it needs to donate proton or it needs to accept proton, there must be presence of other substance, and it could not explain the behavior of this AlCl3 and BCl3 because they have empty orbital. So these are Lewis acids. It cannot, Bronsted theory cannot explain this theory. And next we have hydrolysis of salts and discuss the pH of the following types of salt solutions. Hydrolysis of salts and this types of solutions. This is also one of the important and repeated question. Let us see. It may be defined as the phenomena in which anion or cation or both of a salt react with water producing excess of OH minus or H plus ions. So understand this. So it may be defined as the phenomenon in which the anion, which is having the negative charge, or the cation with the positive charge of a salt will react with water producing OH and H plus ions in aqueous solutions. Let us take one example. Let us see the salt CH3COONA. How it can be obtained? It can be obtained by the reaction of this weak acid, that is the acetic acid, and the strong base. This strong base gives a ionization reaction in which this CH3COONA will be ionized in the form of CH3CO minus and Na plus. And when this reacts with water which undergoes anionic hydrolysis, it becomes the weak acid again. So what this theory states that in the aqueous solution of salt, it is basic due to OH minus ion concentration, and with this OH, if this OH minus concentration is more, then it is acting as a base. If this H plus is more, it acts as a acid. Since it is a weak acid, this OH minus concentration is more. So this pH value is greater than 7. So if pH is greater than 7, it is showing basic in nature. If it is less than 7, it shows acidic in nature. We have took example of this weak acid and strong base. Similarly, we can take strong acid and weak base, and we can define the pH value. And next question, explain the significance of sodium, potassium, magnesium and calcium in biological fluids. So which flows in our human beings, how their sodium, potassium and magnesium and calcium are important. So here Na plus ions participate in transmission of nerve signals in our body, and these also regulate flow of water across cell membranes, and this Na plus ions are responsible for the transport of sugars and amino acids into cells. This is the general question, you need to study it well to remember this. And this K plus ions are useful in activating enzymes, and this K plus ions participate in oxidation of glucose to produce ATP, adenosine triphosphate, and this K plus and Na plus, these are responsible for transmission of nerve signals. So these are the importance of sodium and potassium. And next, magnesium and calcium. This Mg plus 2 ions are concentrated in animal cells. Enzymes like phosphohydrolysis and phosphotransferases contain Mg plus 2 ions, which are helpful in participating ATP reactions, and they form a Mg plus 2 complexes with ATP. So this is the important point. And this Mg plus 2 is a constituent of chlorophyll. So this magnesium is the metal present in the chlorophyll. This is responsible for the green component of plants. So this is the importance of magnesium. And what about calcium? Our body contains 99% of body calcium is present in bones and teeth. So this is also playing important role in neuromuscular function and interneuronal transmission, cell membranes integrity and blood coagulation. So these are important roles of this calcium. And this calcium is present in plasma in 100 milligrams per liter. It is maintained by two hormones. They are calcitonin and parathyroid hormone. These are responsible for maintaining balancing Ca plus 2 ions. This is necessary for muscle contraction also. So this is the role of this magnesium and calcium. And from organic chemistry we have a question like this. Describe two methods for preparation of benzene and explain halogenation and alkylation reactions of benzene. So first we need to see preparation methods of benzene. So this benzene in a laboratory method it can be prepared by this sodium benzoate having formula of C6H5COONA on distillation with soda lime, that is NaOH. It is heated in the presence of calcium oxide. So this gives benzene and this sodium carbonate. A mixture of NaOH and CaO is called soda lime. So this mixture is known as soda lime, and in this way benzene can be laboratory. It can be prepared in the laboratory method. It can also be prepared by the polymerization of acetylene. So here 3 moles of acetylene which is taken in a red hot copper tube at 600 degrees centigrade, it gives benzene C6H6. So this alkylation and halogenation reactions are given by benzene. What happens here? Halogenation, when benzene reacts with chlorine, what happens? There will be formation of chlorobenzene and HCl. And alkylation, that is given by Friedel-Crafts. Friedel-Crafts alkylation, what happens? Benzene reacts with alkyl chloride, that is CH3Cl in presence of AlCl3. It forms methyl benzene. Methyl benzene is formed and HCl is released. So this is about alkylation and halogenation reactions of benzene. So in this way you can expect question, preparation techniques, and the UPSC names etc. will be given from organic chemistry. And the added question can be given in this way. Complete the following reactions and name the products A, B and C. So you have the reaction when calcium carbide, that is CaC2, when this reacts with water it gives A, and in presence of hot metal tube it gives B, in presence of AlCl3 and CH3Cl it gives C. So what is the reaction now? When this reacts with water, that is when calcium carbide reacts with water, it forms acetylene, and when this acetylene reacts with hot metal tube, we have seen the preparation of benzene. What happens? There is a formation of product of benzene. When this benzene reacts with AlCl3 in the presence of CH3Cl, what is it? Nothing but Friedel-Crafts alkylation. We'll get a alkylated product, that is C6H5CH3. So this is, you can expect these type of reacting questions also. So this is very easy question. If you practice well, you can answer it clearly. So these are the few long answer questions which are given previously. So to get good marks, you need to write the complete answer and expand it as much as possible. So in this way you need to write the answer, and thank you for listening. All the very best.